Hey folks, how's it going? In this video we're going to look at solar cells, so let's get started. Now just like light emitting diodes, LEDs, solar cells are also PN junctions. So it says that solar cells are PN junctions designed so that a potential difference is produced when photons are absorbed. This is known as the photovoltaic effect. So looking at this word, remember photo refers to light and voltaic refers to a voltage. So what we're doing in solar cells is producing a voltage from light. And this is sort of like the opposite to an LED, because remember an LED works by emitting light by connecting the PN junction diode in forward bias mode. So instead of giving a voltage to the PN junction to produce light, we're actually going to produce a voltage by giving light to the PN junction instead. And this is known as the photovoltaic effect. So how does this work? Well, it says that when light is instant on a solar cell, the energy absorbed from the photons provides enough energy to raise electrons from the valence band of the semiconductor to the conduction band. This leaves behind a hole in the valence band. In other words, an electron-hole pair has been created. The potential barrier in the PN junction causes the electrons and holes to separate, i.e. the electrons in the conduction band move towards the N-type and the holes in the valence band move towards the P-type. When connected to a circuit, these electrons and holes can then flow, creating a current and therefore potential difference. So we're creating a potential difference from light being emitted onto your solar cell. And you've probably all seen solar cells like this before on the roofs of houses, where you've got lots of solar cells together to form solar panels. So it says here that solar cells are used to store solar energy, which can be used to power homes, spacecraft and satellites. The amount of light instant on the cells determines how much energy they can produce. And when dealing with solar cells, it might be useful to think about the power equations from the electricity topic, such as power equals energy divided by time, power equals current times voltage, power equals the current squared times the resistance, and power equals the voltage squared divided by the resistance. And typically the one involving current and voltage, P equals IV, might be used for solar cells. Just to show you a couple of simulations to help you understand this. So here I've got my PN junction with the P-type and N-type separated by a depletion layer. So if we have light instant on our solar cell, then this is going to cause the creation of an electron-hole pair in the depletion region. And the depletion region itself is going to separate these electrons and holes. So the electron will move into the N-type and the hole will move into the P-type, as shown here. And this will repeat for more photons of light instant on the solar cell, as shown here. And let's do another one. And you can see the labels here. We've got these extra electrons now in the N-type and these extra holes in the P-type. So we've got these extra charge carriers or extra charges here. And then the final step is to connect this in a circuit. So if you connect this in a circuit and close the switch, look at what happens here. So we then get a current flowing. So because we've got extra electrons and extra holes and therefore extra charges, a current flows and the energy comes from the photons. And this can be used to power different devices in a circuit, such as this motor down here. So here's a different perspective of what a solar cell may look like. And just like an LED, we've got almost like a sandwich kind of structure where we've got the P-type material and then the junction and then the N-type material. And you'll see we also have a metal contact and anti-reflection film on the top of the solar cell, just to prevent light from being reflected from the surface and to ensure maximum absorption of the light. So if we zoom in on a side view of the PN junction, you can see we've got it in photovoltaic mode, and if we play here you'll see that when light is instant on the solar cell, we get the electron-hole pair created, and these are separated by the depletion layer into the P-type and N-type materials, and therefore we get charge flowing around the circuit. That's all for this video folks, thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video one of these, subscribe to the channel, and I'll see you in the next one. Take care.